The next presentation is held by Mr. Evaldas Narousis. I hope the pronunciation was correct. Yeah. Green Boats Lithuania is nearly 5 years in the business of electric-driven ships and technologies, ships and boats retrofit possibilities. As partner in our common ELMAR project, Green Boats has the responsibility to build one of 3 demo e-boats. This one, Evaldas will talk about, is focused of the restoration and electrification of an ex-lifeboat. Evaldas is engineer at Green Boats and presents us some interesting technical specs of the used components and test results of the first test drive after electrification of the boat. And after his presentation, we have a little entertaining video. So enjoy the presentation, and Evaldas, the screen is yours.
Okay, I am Evaldas, and I will show you about our project. As Mario told, we are collaborating on ELMAR project, and our idea is to retrofit ex-lifeboat to 12-seat passenger recreational boat. It will have a small cabin and big open deck. And I will tell more about electrical part. Okay. Whole system consists of motor. It's 50-28 kilowatt controller, motor controller. It can run motors up to 60 kilowatt, and the battery capacity is 60 kilowatt hours. And our charger is 3.3 kilowatt, and the system has as well battery management system and some automation. Okay, let's more about the motor. Motor is nowadays very popular permanent magnet motor. It's low voltage. It can run up to 100 volts and can draw continuously up to 400 amps. But as we did some sea trials, we see that 100 amps is maximum what we need. Okay, and so the maximum RPM is 7,000, and we are using maximum 2,000 RPM, and it's recommended. It's not recommended, but we can't reach the temperature of 120 degrees, because at that temperature magnets will degrade and lose the power, and then we need to change the magnets. And the motor has liquid cooling possibility, but for now we don't use any cooling. And after the sea trials, we see that temperature without any cooling was 60-70 degrees. So we will see later, maybe we will install some cooling. Okay, the motor manufacturer recommended to use the MCSO M-Drive 500 controller, and we choose this controller. It can run motors from 30 to 120 volts and can give 500 amps continuously. It can open interface to do some adjustments, configurations, and to see all data online. And it also has liquid cooling possibility, but we don't using. And after sea trials, the controller was only just a little bit warm, so maybe something 30 degrees, not more. Okay, and our main power storage is made of Tesla battery modules. On the picture is shown one module. One module has is made of Panasonic standard lithium cells. Here you can see 74 parallel cells connected, and there's 6 series of those parallel cells. And there is some BMS board installed here, and there's from each of the 6 packs goes wires to the BMS board. As well, there is 2 temperature sensors, and there's also one important thing. Each cell has tiny protection fuse in case there is too much current or something fault. The fuse blows away to protect the cell. Okay, and we are using this configuration. We connected 3 packs in series, and those 3 series connected in 4 groups in parallel. In this combination, we got 75.6 volts at the fully charged state, and if we discharge up to zero level, it's about 60 volts. It's about 60 volts. Okay, and we can put 930 amps maximum and charge as well, but it's theoretical. We don't need that much. We just need lots of we need longer range, but not the more power. Okay, here's one important part of our BMS system. This was manufactured from our colleagues from Klaipėda University. It's based on RAM microcontroller. It has 4 inputs and output channels. With that, we can control our charger and drive, and protect our battery from all kind of faults, to not overcharge, to not too much discharge, and we can equalize each cell individually to keep same voltages, and do not overheat, and so on. Here we can see the user interface of this BMS board. We got the charger information window, the battery, and the motor. As well, we can monitor some information. We can log all data in USB drive. We can monitor voltages, currents, everything, capacity. We can do many configurations for all system, for all warnings, for all alarms. We can enable disable balancing, and we're still developing some options that is needed. On this window, we can see the cell voltages. We can see here that we got 12 modules, and we can see each of 6 cells, the voltages we can monitor. It's the most important thing with lithium cells. It's to have nice balanced cells that don't damage the battery in case of overcharge or over discharge. Okay, and there is some automation, but this is with that system we did sea trial, but now we are improving it, and it will be microcontroller operated to have more flexibility, and to have possibility to control everything remotely from the shore in case. And okay, the results after first sea trial. This is the typical power versus speed relation. We can see that our optimal speed is something about 5 knots, because at that speed we are using something 1.5 kilowatt of the power. But in case we increase speed just a 1 knot, we start using 3 kilowatts. It's double that much. Okay, next graph is according to the motor revolutions. I need to mention that our propeller spins has a ratio of 3. So if we want to know the propeller revolutions, we need to divide in 3. So our cruising speed is something about 500 revolutions per minute of the propeller. And according to this data, we did some estimations. It's just that theoretical. We did not test it yet in practical, but it looks like if we go something about 5 knots, we can have range about 150 nautical miles. If we go faster, so this range decreases. And the same with the time. So if we go about 5 knots, we have something about 40 hours of sailing time. Is I think more than enough, but as I told, that we need to test it in practical how it's, because this is only estimation. Okay, thank you for your attention. And now would be nice to see our video.
So thank you about it for the moment. I expect that Johannes or Romy or someone start the video. Yes, enjoy.
The video is also online on YouTube. You can see the link on the end of my presentation. This is a battery installation. We made special housings for Tesla modules. This is our belt drive.
Okay, thank you, Valdas. Do you want to say some more words, or should you close?
No, there is some question, so I can answer. The batteries is used from Model S, but it's very not many miles on the car, so it's the capacity is still good on the cells.
Okay, thank you.
Okay.
Or is there something more to say?
No, maybe some more questions in case, so I can answer.
Romy or Liane, do we have some more questions? I think it isn't, or?
Not yet, there are no questions.
Okay. Then, thank you, Valdas, for this interesting presentation and the nice video.